So there are 3 levels, level 1, level 2, level 3. In the level 1 and 2 is mainly required for people who are into the business development role, or into the from the IT background, or people who need to understand broadly. I feel anybody joining this company should certainly need to know level 1 and level 2. And level 1 and level 2 takes only a day, hopefully. Level 3 is, it's basically the depth of the training, the depth of the information getting explained. That's what defines its levels. Level 3 is about more about the product, how this, whatever I have explained in level 1 and level 2 is achieved through the software product which we have. So level 3 is involving application of whatever has been explained in level 1 and level 2, and see it happening in level the product. And also it goes to the depth of the product, because there are a lot of configurations, like typically any other software product, you have a lot of configurations. So once we understand level 1 and level 2 and level 3 as we move along, then a lot of screens, the screens which is there in the system, the data which you enter into the system, the report which comes out of the system, you can able to relate to it. So one of the mistake which I found in this company was that either once after the level 1 and level 2, people stop the learning process, so then there is a problem. And there are times I found that the fresh engineers, when they are taken into the company, they are taken into the level 3 straight, without explaining level 1 and level 2. So this was creating a problem, because people were not able to understand what they are trying to do. Starting with introduction to aviation and associated terminologies, there is no need to have any notes or something, just see through it, and I'm just trying to take you through a storyboard. There's nothing formal about it. And this is, let's not get into all that. And this, I think, would need some explanation about how an aircraft ultimately flies. So, I mean, this has nothing to do with the software. This has got nothing to do with what we are going to do, just for curiosity and some sort of information. An aircraft always have, at any stage of flight, including when it's in the ground, has these 4 forces acting on it. One is, if I talk in a very systematic manner, an aircraft has a weight. Aircraft has its own weight, then you put fuel into it, so it becomes added. Then you put passengers into it, again it increases. Then you put luggage, cargo into it, again. So you have a set of, an aircraft has a weight. Now the purpose of the aircraft is to fly, so you need to have lift. So you have to generate the lift. Now how do you generate the lift? What you do is, you have 2 engines, or maybe 4 engines. So an aircraft can have 1 engine, it can have 2 engines, it can have 4 engines. It is, so that's all design requirements. So what is only formula? Allow me to use only one formula, and I promise I will not use any other formula. This is just, without that I cannot explain this. The lift, I'm not getting into the theory of flight, I'm not getting into the aerodynamics, I'm just trying to explain it this way. Only one formula, which says lift L is equal to half rho V squared S CL. Just allow me to use this much, and then you will understand what I am trying to explain. Lift is directly proportional to the density of the air. You have no control over it. In the ground level, you have a higher density air. As you go up with the altitude at 30,000 feet, your density of air is less. So this is an environmental factor. V squared, that's what I am telling. Left is proportional to V squared. That is, what is V? V is the speed of air flying over his wings. So if I manage to put maximum V over my wings, the air, the speed of air over my wings is high, I get a lift which is square of that. So that is my intention now. I have a weight, I have an aircraft weight, I have passengers sitting, everybody is there. I need to put maximum airflow onto the wings. How do I do it? I have engines. So I put the engines on the high power. So that is thrust. So you start rolling out for takeoff. As the speed increases, the airflow over the wings increases, you get a lift. And that lift is proportional to square of the speed of the air flying over it. It is the airflow over the wings. It is also proportional to the S. S is the surface area of the wing. So that's why you see bigger the aircraft, you have a bigger wing, bigger surface area. And CL is the coefficient of lift. That is the angle of attack. I will not get into all that. So the engine's purpose of engines is to create this V square, V. So you start rolling out for takeoff, you get lift, you start feeling the lift. And at some point in time, the pilot, it is all designed for each aircraft type, that speed, the lift off, the pilot has to pull the sticks back. That means he is lifting off. That varies from aircraft type to aircraft type. So it could be at 100 nautical miles or 100 knot speed or maybe at 50 knot speeds. Small aircraft, you can pull it out at 50 knots. Sometimes also it depends on how much of weight is there on your thing. If you have a, so whether you are going for a short takeoff, whether you are going for a long takeoff. So that at that some point in time, you create that, you start feeling the lift and you start increasing the CL, coefficient of lift. That means you increase the angle of attack. That means if this is the wing cross section, if this is the airflow which is coming in, and I increase this, I create an angle of attack. So then the lift further increases. That's why to create this angle of attack, I will more explain what is angle of attack. Suppose this is the cross section of the wing. If I cut the wing, this is a cross section. So when I am moving forward, let's say this is the level at which my wing is traveling. Let's say the air speed, the airflow, this is the direction in which the air is coming. So this is called angle of attack. So what I do, if I can increase the angle of attack by lifting the speed, the wing and this angle, then my CL, coefficient of lift, increases and so that's what it does. That's why when you sit in the window, you see the pilot is increasing this, he put the flaps down. So that basically what he is trying to do, he is trying to increase the angle of attack or increasing the coefficient of lift of the wing. Right? So this is the only formula which I use. Without this I could not have explained it. I will come back to this. So weight, to create the lift, I create the thrust with the engine and hence I get lift. I increase the angle of attack slightly and hence, so lift will increase with V squared, with the surface area which is of the wing and the CL, and I start lifting. That's how you take off. And once you take off, once you have a forward motion, you have an airflow against you, and that is what is the drag. This is the drag. That is a drag offered by the air resistance. So the complete flight of an aeroplane is manipulation of these four forces. A complete aeroplane flies L, lift, weight, thrust, drag. So pilot, by manipulating the controls in the cockpit, is either increasing the lift or increasing the thrust. Weight, he has no option because when he took off he had a weight. And drag also is based on the airflow against it. So it generally manipulates the lift and the thrust. Either he increase the engine power, if he is at 30,000 feet and if he wants to descend. What he does is that he reduces the thrust and slightly, the engine power gets slightly reduced, the weight will take charge because the weight starts sinking. And so and when you come for landing, again, you are coming with the whole weight. You want to, so it's a manipulation of these four forces is the complete flight. Again, nothing to do with the software, just for general understanding. Okay, go on. And this is some of the parts of an aircraft, just again not for any, typically this is a small piston engine. An engine of an aircraft can be generally, if I do a broad categorization, it can be piston engine or it can be jet engine. Piston engine, old aircraft had this piston engine, smaller old aircraft. So they used to, this is a piston engine. Now most of the fuel used to be petrol. And now the bigger aircraft has jet engines. So a jet engine can be a turbojet engine or turboprop or turbofan. Don't worry about it. This is just nothing to do with the software. I'm just trying to take it. If you have seen some of the propeller aircraft, so that's a turboprop engine. If you go to an Airbus A320 or Boeing or something, you see there's no propeller. It is just a turbojet or a turbofan engine. You have a fan. Like if you see that, you see blades there. So it's a turbofan engine. Most of the fighter aircraft has a turbojet engine. So, so engines, landing gear.
It's a turbofan engine, sir.
Which one? No, this is a piston engine. What you're seeing is a piston engine. Here. This is a small aircraft with a small propeller, you can see that. So it's a piston engine. Piston engine is also called as reciprocating engine. Nowadays you will see that smaller Cessna, Piper, small aircraft which are there in the flying schools. They generally use this piston engine. In the Navy, there used to be an aircraft called Islander, which is now phased out. They used to have this piston engine. But this big passenger aeroplanes like Airbus, Boeing, they do not use the piston engine. Now, landing gear is a terminology used to represent the wheel assemblies of an aircraft. It's called landing gear. So you have a nose landing gear, you have two main landing gears. Main landing gear LH, left hand side, main landing gear RH, right hand side. Some of the old helicopters, even now, they had tail landing gear, tail gear, like Sea King helicopter of the Navy. If you see that, it doesn't have a nose landing gear. It has two main landing gear, LH and RH, and a tail landing gear. So when you come to a landing,
land nose down.
Yeah, they will feel the tail. First they put the main landing gear first, and then put the tail down. That way, when you come for if you have a normal landing gear also, you come and touch down on the main landing gear, then you roll for some time, then you put the nose landing gear. You always come, the aircraft geometry is like that, you always come like this. It's very difficult, pilot has to, unless pilot does something very, very drastically wrong, he cannot come and land on the nose landing gear. So the geography or the geometry of the aircraft is like that, the center of gravity is adjusted in such a manner. When it sinks and when you come to the runway for landing, you first touch onto the main landing gear. Main landing gear takes the maximum shock in the impact. Then you roll on it for some time. Then you put your nose down. And so nose gives you the direction. Then you start getting the direction. So this is called landing gear. Nose landing gear, main landing gear. When you go for implementation, this jargons generally people use. Some of the data which you get says main landing gear LH, so many hours, so many cycles. So I'm just familiarizing you with certain terminology. And this is also, landing gears are also called as undercarriages. That's another way too. These are all jargons in the domain. Landing gear, undercarriage. So if you say main landing gear or main undercarriage, LH, sorry, or nose undercarriage. And the whole body of this aircraft, we call it as fuselage. Fuselage. That is the shell. Like in the car you say the body of the car. So similarly, fuselage. And obviously everybody knows what is wing, right? And this area, this is called vertical stabilizer. Vertical stabilizer. This is called horizontal stabilizer, which is horizontal to the ground. Don't worry about it. It is just it. I mean, if you want to write, please do write. But these things, these terminologies you come across. So that's I'm just trying to familiarize you with these terminologies. And aircraft has three controls, three primary controls. Any aircraft has three primary controls. And helicopters, I'll come to that. It is, theory of flight of helicopters is a little different. The same formula will get applied there, but it gets applied on the, there's no wing, so you have your main rotor becomes the wings. So by rotating the main rotor, what we are trying to do is you are putting that V square. By starting the engine and the main rotor is started, each blade is a wing. Like if I talk about a helicopter, if I talk about a helicopter, it has a main rotor. When you are rotating, you have an engine here, you have a gearbox. So the engine gets started, and how an engine gets started, just for curiosity, because you have each engine has, again I'm getting into the depth, but I think it's worth, if there's an interest I will explain, otherwise I will.
Yes, please.
Yeah. So an engine has so this is the front side. Let's say this is forward looking to the thing. So you have one area called, this area is called so air is flowing into that. This is atmospheric air, normal air. So in this you can see the fan here. I told you about turbo fan. So you have the fan here. So this fan is, this is called air intake. Air intake. This is the air intake area. Then you have a, so this is a shaft here. This is a common shaft running in. Air is getting in, and then you have to, this area is called compressor, engine compressor. So you have, on the shaft you have blades. This is, you have metallic blades. And this area is called combustion chamber. This is where the actual heating, the burning of the air and the fuel happens. So from the aircraft fuel system, you have the fuel coming in, fuel line coming here. And the air is coming from here, right? And here the combustion happens. This is where the whole thing gets burnt. And after that, you have, this is the turbine section. This is called turbine. So this is called compressor. So you have an air intake, you have a compressor, you have a combustion chamber, you have a turbine, and this is called exhaust. And the burned air goes out. So, actually this is the situation. So what happens is, when you are starting an aircraft, first you have to create a motion. Then only all this process will start. So the first kick is given to the shaft. You have a gearbox or something here, which is connected with a starter motor. This is like how you start a car. So the pilot switches on the start button in the cockpit. This electric motor energize, and the gearbox will start rotating, and which is connected to the shaft. So shaft start turning. So once the shaft start turning, obviously this air is anyway there in the atmosphere. So air gets slightly sucked in, then this compressor compresses it. So you get a compressor here, a compressed air coming in here. And when this RPM of the shaft reaches somewhere around 50 to 60% of the rated speed, this fuel line opens. This is the fuel valve. This is all automatically happening. So this fuel line gets opened, the fuel starts coming in and burns, and when the burned air goes out, it transfers energy into the turbine blades. So turbine blades take out that, and that is what is rotating the shaft, and the hot air goes out. So this is what happens in a jet engine. So so all these terminologies, when you go for implementation, you will see compressor blade number 12. You know, ours is so many cycles and so many. So you need to visualize. Okay, this is the compressor is. And somebody says, suppose somebody give you data telling combustion chamber turbine blade, you can always ask, is it a typing error? You know. So when you go to the airline, you will get all lot of type of data. So this is the reason which Anup, I was telling, this data entry is not a typical mechanical data entry. You need to understand what this data is about. Otherwise, if you take a typical BPO data entry people, if he puts the turbine, the compressor blade value into the turbine blade, the values are different. You know, the temperature which the compressor goes through is not so high, whereas the turbine blade goes through huge thermodynamic cycle. Like every start of an engine, the turbine blade goes through from, let's say the atmospheric temperature is 30 degrees. With one start, it goes to maybe 20,000, 30,000 degrees, right? Or then it varies from engine to engine, keep it as even 10,000 degrees. So it goes through that and then comes out. I mean, it's a thermodynamic cycle. So while in the flight, you will have roughly around 1,000, 1,500 degrees. And these turbine blades are in different stages. So you'll have compressor first stage, second stage, third stage, fourth stage. Bigger the engine, you will have more number of stages. Turbine, first stage, second stage, third stage. So let us say this turbine blade is made of alloy. It goes through, with every start, it goes through a thermodynamic, temperatures, forget about 10,000 degrees, take it only as 2,000 degrees. With the 2,000 degree, you can see every cycle you go through that. So the amount of thermal stresses which happens on a turbine blade is huge. So this is one of the, so each of this turbine blade has a life. It says maybe 20,000 cycles. So this blade has to be replaced after every 20,000 cycles, basically after every 20,000 starts. If a software is not good or the user did not change it, this 20,000 cycles, the blade will continue to fly for 30,000, 40,000, and one fine day it will explode in the air. It will just detach from the shaft. And the shaft, typically the RPM is to the order of around again 5,000 to 10,000 RPM, or even more than that. Jet engine has a much higher RPM. So you can imagine if one small bit of this turbine blade gets detached in the flight, it will have a cascade, it will damage the complete turbine section. It's something like somebody putting bomb into the engine. So there is a lot of airworthiness and safety related aspects into this. Our software is basically to monitor such things. So anyway, I am digressing, let me come back. So there are three, I was talking about the controls. I talked about the engine, now flight controls. There are only three parts of the aircraft where one should not take any sort of a chance. One is obviously engine. Second is flight controls. Any defect in any of these systems should be seen with seriousness. And third is undercarriage or landing gear. So these are the maintenance engineers have been taught, or the seriousness with which a maintenance engineer looks at an aircraft defect. If he's a sensible maintenance engineer, he will never take chance with these three systems: engine, flight controls, undercarriage. I talked about engine, I talked about undercarriage. I think let me talk about flight controls in brief. There are three primary flight controls, or an aircraft in flight goes through a three-dimensional motion, unlike a car on the road. Like one is an aircraft or a ship goes through, one is called pitching. Like you do like this forward motion. This is, if I talk in terms of like this is an, let me try to draw. My drawing is pathetic. Let me try to. Nitin, are you good in drawing an aircraft? Let me. Yeah. You can assume as a fighter as well. So, the nose is a little too big. So this is where your nose landing gear is. This is where your main landing gear, your wings are here. Yeah. So when you're flying like this, the aircraft, this nose goes up and down. That's called pitching, pitch motion. And with reference to this axis, the aircraft will have a tendency to move this way. That's called roll. That means this motion. Left wing down and right wing up, and vice versa. This is a rolling action. And third is called yawing action. That is, if you're flying like this, with the same axis, you have a tendency to left and right. Or the car, I can't use the word yawing, but turning left is almost like a yaw. You're writing right yaw, left yaw. So, pitch, roll, yaw.
Sorry, sir, I forgot.
Yeah,
Pitch.
Pitch is like, or imagine you must have sailed in a boat or something. When you are going over the sea, a wave is coming, you climb over the wave. Yeah, that you are climbing over the wave and coming up. That is the motion. The car, we don't face this, or in a bike, we don't face this, because you are on a road. You generally, like when I go for my lunch, I see some of the youngsters going in a bike. Zoom, he goes. He's yawing actually to the left or right. So in the aircraft, actually, when you're flying, if you want to turn to the left or right, you don't do like what you do in a car. What you do is you slide. If I'm flying like this, I want to turn left. I don't abruptly put my controls to the left. What I do is I do a roll first. I do a roll and then put the control. So it's a coordinated left turn. It's called coordinated left turn. If you try to do zoom left like this, then the aircraft will skid. Like that's what happens. Most of the youngsters I see falling down, and this is because of this. They're going in high speed. Zoom, they come and they skid. Actually, what you should be doing is a coordinated left turn. Then you would not fall down. So in the flying, you have this. You are flying. You want to take to the left turn. You first do a slight bank. It's called banking the aircraft. You put the left wing down. So you do this thing. So automatically the aircraft will do a coordinated left turn. So it has a turning radius. I'm talking about while in the air, and in the ground. Obviously, when you are taxiing in, you are in the ground, so you don't do a coordinated left turn. You can't put your left wing left and right. I'm talking about while you are in the air. Please stop me wherever you are. I'm finding there's nothing to do with the software. Just take it easy. These are just normal talk. Pitch, roll, yaw. Now, I told you the engines gives me lift. As any aircraft flyer, my intention is that I have a passenger too. I mean, we have a passengers and the weight to carry. That's my intention. My first intention is how to lift it. So I have my engines, create the thrust, your V squared, you lift off. Now once you lift off, I need to control the aircraft. So I will come across the requirement of maybe I'm putting it, I have to further climb, after takeoff, actually keep a pitch motion. Actually I'm on a continuous pitch. I'm flying, I'm climbing. While climbing, let's say I see a cloud coming in and I get into that, then you have a pitch motion maybe, automatically. Sometimes you get a pitch and a roll together. That's called corkscrew motion. Corkscrew motion. So you get into some severe weather, the aircraft will experience a pitch and a roll, so you will see that corkscrew motion. The same thing happens in the sea, at sea. Actually in a much worse situation than what we've experienced in the air. In the sea, when your ship is out at sea for maybe 10, 15, 20 days, you come across bad weather or maybe cyclone or something, you climb over a wave, that's a time the other wave coming from the other side and the ship experiences a corkscrew motion. And you will see the structures, the ship structure squeaking. That sound will come. In the aircraft, you don't face it because most of the sorties are just 3-4 hours. And generally the pilots have there's something called a weather radar in the cockpit. So in the weather radar, like you can see, the weather radar antenna will be fitted in the nose. You can see a small little black thing here. It's a radome. Inside you have an antenna which will keep scanning, and in the cockpit you have a weather radar display. So this weather radar can detect almost around 30 to 40 nautical miles. 1 nautical mile in the land we say 1 kilometer. Right? That's why I say 10 kilometers, 5 kilometers. In the maritime and the shipping, they use the word knots, nautical mile. So 1 nautical mile. One nautical mile is equal to 1.76 kilometers. So if you are asking a pilot what is the speed, he'll say, 100 knots. When you say 100 knots, it's 100 nautical miles per hour. Like when you're driving a car, it's a 50 kilometers per hour, we say that. Similarly, there, the distances are explained in nautical mile. Actually, it is not K, sorry, it is N. NAU, nautical mile. NAUTICAL. Okay, coming back. So 1 nautical mile is equal to 1.76 kilometer. In the ship also, at sea, when you pass the position of the ship, yes, they talk in terms of nautical miles. We are 100 nautical miles from the shore, or we are making a 20 knot speed. So they all talk in terms of not in kilometers or miles. So flight control. Now how do we pitch an aircraft? So you need to have a control to pitch the aircraft. And this is where, I told you about the vertical stabilizer. Here you have 2 movable things here. I call it as elevators. Elevators. This has a motion like this. So what I do is, let's say this aircraft is flying like this, the air is flowing this. So this elevator can move up and down. So once I increase the angle of attack, CL, I told you, coefficient of lift. So by moving this, what I am doing is I am manipulating the CL, coefficient of lift of this surface. So if I increase the lift here, naturally my nose will dip, because my center of gravity will be somewhere there. So if I increase the lift here, my nose will dip. If I decrease the lift, or I create a lift like this down, my nose will lift up, because the center of gravity is here, somewhere here, right? So this elevators gives this pitch up and pitch down motion. So when you, after takeoff, the pilot will put this on full pitch down, full down or full up, maximum, reduce the lift here. And similarly, don't worry about it, this is just for nothing to do with the software or something. I'm just experiencing you with some jargons, that's all, exposing you to that. This, if I want to roll the aircraft, what do? If I increase the lift here on the left wing and decrease the right wing lift, I will roll towards right. This will go up, this will come down. So this rolling to left or right is again by adjusting this control surface, this here. This is called aileron. So aileron, I write it. So one is elevator. So elevators are fitted on both the horizontal stabilizers. That is for pitching up and pitching down motion. Then you have something called aileron. A-I-L-E-R-O-N, aileron. This ailerons is for rolling the aircraft and for yawing, that is left and right motion. This is called vertical stabilizer. On the vertical stabilizer, you have something called rudder. R-U-D-D-E-R, rudder. So you turn the rudder this way, so you have a lift getting, everything is related to the lift. So because the airflow is there freely available, I manipulate my position in such a manner that I create lift or drop the lift, then I get it. So if I have a lift going that way, my nose will turn left. So in the pilot, in the cockpit, what happens is, the pilot is only, he is having a, that's called control column or a joystick. Control column is a better way, it's a more technical language. You have a pilot has a control column, co-pilot has a control column. So both follows each other. If pilot is turning right, the co-pilot's control column also will turn right. And otherwise you will have multiple inputs going into the aircraft systems. So pilot turns left or co-pilot turns left, you will see the pilot's control column also turning left on its own. So when you are, by doing this, what actually happening is this three controls are getting manipulated. So based on that, the pitch, roll and yaw as, so you're understanding this aspect, right?
Rudders are fitted on that side.
The rudder is fitted here, and the back end. So it's like it is hinged over there, so it has this motion. And like when you are coming in for taxi, let's say you landed, you have reduced the speed, you come into the taxi, then your rudder will not be effective because airflow has stopped. You are just getting very less air. So that's the time they use the nose gear, nose landing gear to steer it, like a car or a bike. In the air, you use the flight controls. So actually, it is using the air. This is called aerodynamics. This is called aerodynamics, the whole thing. These are formulas and multiple things and all that. We are not getting into all that. You must have learned all that. Yeah? So there are derivations out of which, it goes on. In my training also learned all this, but I can tell you in the airline, commercial aviation, I have got my license. I can tell you with authenticity, there was not even one question which was related to any formula. The only formula you need to know to become an aircraft maintenance engineer is V is equal to IR, Ohm's law. That's all. No question about this will be coming. So there is no derivation, there is nothing. I'm telling you, I'm serious. And this also I used to remember as very important relation. V is equal to IR, right? So as a maintenance, when you do a B.Tech in aeronautical engineering or all that, aerospace and all that, then they get into all this analysis of this, fluid mechanics and Bernoulli's theorem, all that will get in. But to become an ME, all you need to do is to know this. And so that's why when you do the recruitment of people, when I recruit people from B.Tech or when I interview a person with AME background, one need to be aware of all these things. Okay, so elevator, so these are the primary flight controls. primary flight controls. Like for example, after the takeoff, so when I'm on a takeoff roll, I put my engine on full speed, full power, I leave the brake, start rolling, air is coming in, so I get a natural lift. After some time, you will see the control column itself, you start getting that feel. All you need to do is just give a little thing, it will take off. Because of this, control column will start feeling that. Then you keep the elevator up, keep it on a pitch up, nose up attitude, it keep climbing. And now let us understand what is the different phases of flight. You're with me on this, right? So then these are all primary flight controls, and sometime in the flight you hardly need to, if you want to turn towards left, you don't actually have to manipulate the aileron itself. You have small tabs associated. So a portion of the aileron, maybe this portion, only I need to just manipulate that. So aileron tab. You don't have to move the full aileron. What I'm trying to say, the aileron is divided into two parts.
Is it like a flap?
Flap is here. This is flap. Flap is not used generally in the flight unless flap is generally used mostly during the takeoff. You must have seen the flaps being lowered. What you are trying to do is the pilot is trying to increase the that is the surface area of the wing plus CL component. This is what he is trying to do. Similarly, when you come for landing, you put the flap. It can act as to reduce the speed also. You are trying to stall the aircraft. You want to come down from 30,000 feet. You come to around 10,000. Slowly you descend it. Now your runway is, let's say, around 10 nautical miles. So you want to drop your altitude fast. By the time you reach 10 nautical mile, you want to kill the altitude or reduce the altitude. You increase the flap. You put the flap down. It will act like it will increase the drag. So flap is used for during takeoff for increasing the lift. But while landing, the flap is used to decrease the lift and act as almost like an air braking effect of reducing that. So flap is this. Flap is not regularly used. It's not used to control the aircraft on for these three motions. In the normal flight, if we are, let's say, you want to slightly adjust the aircraft is flying slightly, let's say on a bank mode. Sometimes it happens, and the pilot realizes it, so he just give a small correction. That correction is generally done through not the full aileron, maybe a tab is okay. Basically, a primary controls and secondary controls. That's what it is. And now the last bit of this information is the.
So is the secondary control the finer one?
Yeah, that's a finer one. Yeah, because what happens is, I'm moving a little more inside. Aircraft has something, aircraft and ships also, they have something called autopilot. So after takeoff and you climb, once you are around 3,000, 4,000 feet, you engage your autopilot. Then the autopilot system takes care of the aircraft. So what the autopilot system does, it has the sensors to sense the aircraft attitude, whether it is left or right. So it has sensors, and the sensors are generally, I'm sorry I'm using a little bit more jargons, but interesting I suppose. It is VG, vertical gyro. It has vertical gyro. So normally if you want to see the direction of an aircraft, how do we do it? How do we sense the direction of an aircraft? You have a gyro. Now I need to explain what is gyro. Gyro is, in the olden days in our school we learned this, I don't know, in English they say top, in Malayalam they say pampara, right? I don't know how many of you. So it's a gyro. So what happens is, a gyroscope has, it's like a flywheel, no? You run it at a high speed, it has a stability in that. Gyro has three properties. If I'm trying to rotate a, let's say, disc with reference to an axis, more the speed it is, I have a stability with reference to this axis. So gyro has three properties. One is stability, next is precision, and third is one more, I'm forgetting. These are old physics time. So if I'm running this this particular gyro, this particular plate, it's like a flywheel. You will see that you have a stability with reference to that axis. Then, let's say, imagine a situation that you are running a flywheel at a very high speed. You try to give a force here. Try to push that plate little. The effect of that force is left 90 degrees ahead, and actually the plate will start moving in a different direction. This is called precession. So gyro has two properties. One is stability in a particular axis, and third is precession. Right? And it's not precision, it is precession. It is P-R-E-C-E-S-S-I-O-N. Precession. So gyro has two properties. This property is used in the ships and the aircraft to sense the direction of the aircraft.
Even our smartphones have gyroscope. All our smartphones.
Yeah. So,
Qualifies as an what part of maintenance qualifies for an overhaul?
yeah, we'll come to that.
Okay.
We'll come to that. I think that's a limit. When we go to level 2, we'll come to that. But it's a good question. We are flowing there. That means I am talking in the right direction. So this is what about it. Some of these things which I told you, will come to that later. But I'm just trying to build that story going. And when there is a break, please tell me. Anybody want to walk across and take a break? Please feel free. I'll try to. What do you think? Should we stop now?
You decide.
Yeah.
Or one sec, let them decide.
No. See, smokers have their own issues. Yeah. So he's trying to be very diplomatic on this. And how many more slides are there?
It's like 23 slides on the 7th slide.
23 slides for level 1.
Yes.
For level 2.
Level 1.
Oh my God.
Okay.
Oh, okay. Then
Quick break, 5 minutes?
yeah, 5 minutes break. What do you think? Huh?
What's the usual lunch break here for
Anytime. Norwegian, British Airways, all that. So let's move on. These are the regulatory authorities in the aviation. Each country has a regulatory authority, aviation regulatory authority. And in India, they are called Directorate General of Civil Aviation, or DGCA. In Europe, they have called European Aviation Safety Agency. It is pronounced as EASA, European Aviation Safety Agency. And in US, it is regulated by Federal Aviation Administration, FAA. In Gulf countries, you have Gulf Civil Aviation Authority, and this is, I don't know, some country. All said and done, the majority of the aircraft manufacturing activities are focused in US and in Europe. Airbus is in France, Europe. So Airbus manufacturing, the design, type certificate issue, all that is overseen by EASA. So Airbus manufacturing is controlled or regulated by, and even aircraft operators based in Europe is also regulated by EASA. So the Aviation Regulatory Authority regulates design activity, manufacturing activity, operations activity, maintenance activity, even training activity of the operators. It's all regulated by that. DGCA is fortunate or unfortunate. They get to regulate only the operations, maintenance and training, because nobody is manufacturing it. And the manufacturers in India are only HAL. That is in the scope of defense. So DGCA do not have, these are all civil military certified aircraft. And civil certified aircraft are regulated by DGCA. So there are some ALH which are manufactured by HAL for civil operators, like BSF. BSF, though it's a home ministry, they are ready what the pilot was talking at that time. Some people say somebody's, oh my God, you know, these sort of exclamations come in the cockpit. Oh my God, we didn't do this, you know. Then they know that this was these chaps would have died by then. But then you will, you will know what has happened. Like I don't know, I saw a WhatsApp message where a crash happened in, I think, Lion Air aircraft. The aircraft took off. Now, suddenly we started doing this. Suddenly, uncommanded flight inputs were going into the system, auto flight control system. The aircraft suddenly, vertically it is climbing, suddenly it is coming like this, then the pilot is doing something, so nobody knew what has happened. And ultimately it went and ditched into the sea. Everybody died. Now investigation has found out that there is something called angle of attack indicator, that alpha which I told you, that there is a sensor it is fitted outside the aircraft, it's called angle of attack indicator. That was malfunctioning, whatever. Now this was giving wrong inputs into the autopilot system. And autopilot system was, and I believe that there was an attempt to make this artificial intelligence in the aircraft. So aircraft understood that, like if a pilot was flying, if I get an angle of attack indicator wrong, I can sense it. I know that this is, normally I take over the control and I start flying manually. Now when you put it too automated, then this sensor inputs become critical. They see it as angle of attack indicator malfunctioning as suddenly the aircraft is climbing. That is how the computer is understanding. So they give the correction to the autopilot to dive. So this is what has happened in that crash. So more automation, when we talk about artificial intelligence and all, when we are giving the demo tomorrow to those people, we need to moderate it. You know, this is, if it is not moderated, then you will end up in very. So as the technology develops, there will be a phase wherein the technology will be good, but then not safe, especially in a domain like aviation. So one has to be very.
That we are facing in the automated car industry also. Autonomous cars.
Like autonomous car, in maximum there will be a driver, and even if he doesn't have to, driver need not be there. But here, look at the stake. You are carrying 150 passengers, and one crash of one type, your complete debranding happens. Let's say tomorrow ALH had a couple of crashes, but it was mostly pilot error. But imagine, you developed a new aircraft and you are trying to capture the market. These fellows are marketing all around, and suddenly one operator goes and crashes it, deliberately or unintentionally. Nobody crashes it deliberately. He gets killed anyway, his pilots. But this guy is also affected because his brand name goes, oh, it's HAL, no? It's, I say. So this is, so this ecosystem is a very sensitive ecosystem. Unless the people here understands pretty well what they are up to, you can have problems. Anyway, so some of the maintenance tasks, so this is called maintenance program. The manufacturer, when they type certify an aircraft and given to production agency, when he gives the handing over the aircraft, he has to give a maintenance, it's called MPD, maintenance planning document. So each type of aircraft will have its own MPD, maintenance planning document. That will say what are the maintenance tasks, what is the hard time limits of each maintenance task, or what are the hard time limits of the component replacements. On condition means which is not covered in that. What are the condition monitoring program which can be permitted, and how to do that condition monitoring is left to the operator. He may not, manufacturer is not bound to tell him. If you are doing engine condition run monitoring, manufacturer will say you should do it. How you do it, whether you use a laptop, whether you use an Excel sheet, whether you use a manual graph record, whether it is a software, that is up to him. Whether you use artificial intelligence, whether you use data analytics, so it's all up to the operator. Sure, move on. So this is what I was feeling.
Yes.
Aditya is feeling sleepy because I think, how many more?
Sir, 4 slides.
4 slides only. Can I just finish it off so that we'll go with a... This is a pilot who landed with only one main landing gear. It happened in Bangalore. Praveen Kishore, the Coast Guard pilot. He was flying, he was being trained for QFI as an instructor. He was flying for Coast Guard, then he went for training with the Air Force to become an instructor. So to do the instruction duty, you have to do it. That's another trick. So it was in the Air Force Station Elanga here. So he took off with a pupil, with an understudy fellow on the controls. He took off. At this phase, when he was taking off, the right side main landing gear wheel fell off. So the ATC, he did not realize, ATC told that your one wheel lost. Now in the Air Force Dornier, what happened, in the Coast Guard Dornier, what happens is you can dump the fuel. See, when you take off, you have the full fuel with you. Now you can't come and immediately land because your takeoff landing weight has to be less than a particular weight. So you have to go and dump your fuel. So what we used to do, if you have an emergency during takeoff, you take off, open up to the sea, you dump your fuel, the maximum fuel you dump it onto the sea, then you come for a landing. So your weight is less now, you do handle that. Air Force Dornier did not have this fuel dumping system. So for 4 hours, this guy was in the air without a wheel. He is burning the fuel. So on one side, he was telling me this. He says, "Sir, I have one trainee on my left side, and I have no wheel. On one side, I have no wheel. And these fellows do not have a dumping system." For 4 to 4.5 hours, he says, "I don't know how much." The trainee start panicking, because obviously he will start panicking because he didn't know how he is going to land. Now, 4.5 hours he's burning, he's loitering around Bangalore, I don't know where all he went. Just imagine the situation. Then he came for a landing with one wheel. Just imagine that situation. The complete ATC was manned and AOC was in the tower, and they were trying to boost him up on communication. Don't worry, we are there, that sort of talk. And they put this crash fire tender on both sides. This crash fire tender is like a normal fire tender pumps out water. For the aircraft fire or oil fire, if you use the normal fire tender with water, it spreads, the fire spreads. So what you do is you use a crash fire tender which pumps out foam. So this foam goes and sits over this fuel, aircraft body as well as the fuel and all, oil and all. So, and it cut off the sort of oil, oxygen supply. Like fire is a fire triangle. No? The fire triangle, a fire happens when you have oxygen, when you have a combustible material, and then heat or fire. So you put the thing on it and cut off the oxygen, and the fire goes off. So that's the typical aircraft firefighting thing. So this guy came, they put this foam, so when he come and touched, so he came, he said he lost the first, this one. So he came, as it is he came like this. And both the crash fire tender was going in a speed and putting foam into the runway. So that when he comes and hit also, because at some stage he will have to drop his right. And that wheel axle is metal and it's at a high speed. He's coming at 200 nautical mile speed, which is almost 250 kilometers. Now, at that speed, if this metal goes onto the runway, spark and all that, and these fuel tanks are generally on the wings. So the spark will start flying into that, somebody will, that, fire will start with the fire. So to avoid that, they put this, so he came and he touched down on the left, this thing, he rolled as much as possible on that. And at an appropriate time, of course he put the nose also, so he got two support. He says at some point in time, and he lost the brake. See, the brake is on the tire, wheel. If your wheel itself goes, you cannot brake. So you have to brake on the left tire only. And once a tire goes, and he had a hydraulic failure also, because the hydraulic line will get ruptured and all your hydraulic fluid leaks out. So he doesn't have brake. He has only one tire and a nose tire. So he dragged, and at some point he put his, and he saved. Both trainee and the instructor saved. So this happened in 2000. I was posted in Bangalore. So when this emergency happened, I got a call from, when this fellow was loitering in air, I got a call from Air Force Station, Yelanga, AOC. He said, one of your pilots in the air, he doesn't know field. But then he managed it. So this is chokes, then he comes in, he chokes on. So the time between chokes off, this time, chokes off to chokes on, this is called block hours, because from the system, for incrementing the airframe hours and component hours and all, you need 2 times. The time between takeoff and landing, or airborne time and touchdown time, this is called time in air. This is the time the aircraft is in the air. This is the time which is used to, we capture after the sortie, what is this time? And moment you put this in the system, the complete airframe, engine hours, component hours get incremented by this hours.
What's the first?
This is called block hours.
Block hours.
This is used, so one is the flying hours or flying, whatever, the time in air. Block hours is used to increment the pilot's flying hours. Like one is the aircraft flying hours, because moment the chokes are removed, the pilot is on alert. Because taxiing and all, he has to be in alert. So all the FDTL rules, pilots, training, licensing, all that is handled. There are a lot of complex, these are all handled using this block hours. So pilot, correct, we are using block hours for it. And for all engineering activities, we are using flight hours. And we want to use the fuel consumption. We have reports which can be generated using the fuel consumed from this sector to that sector, that station to this station. Either we can divide it by the block hours. Engine is running now, even if we are taxiing, though there is no much power in that. Like when taxiing, the engine power is only around 10%, not even 10%, 5 to 10%. You just give a kick. But sometimes some operator says, no, we want it in time in air, fuel consumption. So these are all the areas where a lot of AI opportunities are there. This is about, this is something about the fuel calculation and the weight management of the aircraft. From our system perspective, we have a module called load and trim module. Then you calculate the CG based on the fuel you have uploaded, the passengers and the cargo distribution. Then you calculate the CG, and the CG will have a max and minimum limit. So for every sortie which you are flying, the CG should be within this limit during the entire sortie profile. If the CG goes beyond forward limit or aft limit, the aircraft will become unstable and it could be a crash. So that's the reason this load and trim is calculated. In such cases, these weights are important. That's all. Yeah. Okay. This is CG is center of gravity. And for the aircraft, they say, for the ships also, they have something like that. Your son must be knowing certainly. Anu's son is in the Merchant Navy. He's a very accomplished mariner. For the ships, what happens is they calculate CG, and they have something called meta center. So meta center and CG. This is called metacentric height. So I am not exactly remembering now, but if this is during the loading, suppose you put the cargo here, fuel tanker, all that put together, every time they calculate this CG and the metacenter. If the metacentric height, a metacenter goes below the CG for some whatever reason, the ship will topple. It will not capsize immediately, but out at sea during a sort of weather is bad or something, it can capsize. So in the ships we used to calculate it every day. Like it's an engine officer's job based on the ships, based on the fuel in each tank. And the ships you have something called a ballast tank, where you put seawater. You take seawater from the sea, and that's for ensuring the stability. Then fuel, like I remember when we used to sail, we used to carry almost 80 kL of diesel. 80,000 liters of diesel in the fuel tank. Almost around 20 kL of aviation fuel for the helicopters. And if my memory is correct, around 150 kL of fresh water drinking, because at the sea you can't drink seawater. And every day we were generating 5 kL of fresh water from the seawater. Like what we do is, the engines are running, so you have a lot of heat. So what we used to do is, it's a system. So you take seawater and you make it circulate over the engines. There are lines. So the engine heat will increase the temperature of this seawater. Then this circulated water is brought into something called an evaporator. The system is called evaporator. Here you maintain a negative pressure, vacuum. So under the negative pressure, even at a 50-degree temperature, the water starts boiling. So you take seawater, circulate it over the engines and the generators, bring it into the evaporator system, where vacuum is maintained, then it starts boiling. So you boil it, and the steam goes and deposits, distillation. Then you allow it to take it into the next tank, and then you put a salinometer here. It's all in the system. If the salinity is more than drinkable permissible limit, again it comes back here through another line. So if it is okay, you take it into the freshwater tank. So in this way, every day we used to generate around 5 kL by the main engines and 5 kL by the generators. So you are 150 kL, otherwise 150,000 of liters of water, you have around 100 people on board. 3 meals when you cook for 100 people. And their washing requirement, taking bath, and we used to have water routine. So in morning 5 minutes, just 5 minutes only water will be available, fresh water. Evening another 5 minutes. That's the time only you can take bath. Yeah, 5 minutes, 5 minutes. 100 people have to take bath in this 5 plus 5, 10 minutes. So there is nothing like people standing in the queue waiting for the bathroom to get in. So we used to have a free-for-all thing. Like if you enter into the officer's toilet, you will find everything is on a free-for-all thing. And if you are an engineer officer, you have a privilege. When I want to take bath, I will tell my staff, open it. So that privilege is there. So most of the people used to take bath. When the engineer officer goes for taking bath, then people used to tag along, because you know what is going to be opened. And in the submarine, you can't even have this privilege. The submarine. So in the submarine, that is the reason people are permitted to grow beard. In Navy, you must have seen people are permitted to grow beard, whereas not in Army or Air Force. The reason is this: you don't have the luxury to shave every day. In submarine, also of course, in the submarine, even your clothes are disposable. So when you sail out, you will have disposable garments. So after every day you dispose, so you can't wash it because of water restriction. Anyway, that's separate. And
Beyond the CG level in aircraft, what would happen, sir? It's hard to take off.
no, aircraft will be, I will say it will be an unstable equilibrium. So what will happen is it can crash. It can crash. And this generally happens when you are trying to fly the politicians in the helicopter, no? Especially during the elections. In the, when you are, what happens is, suppose you are going for an election flying, one fellow must have asked for it. You must have paid for two people to come along or something. And when two people are sitting, you will see a third jodi coming and sitting. He wants to, so minister says, usko bhi aane de. So you permit him. When you are about to start the engines, then you will see some people come with something to dump, some luggage, I don't know what. So all these rules get violated mostly during these politicians I'm just telling, these are the cases which happened. I know a case where in Jaipur was a crash happened. One small aircraft took off. One actress, Kannada actress was there, and you must be remembering that.
Yeah.
That was a case of this overloading. Forget about load and trim calculation. They would not even bother to even see whether it has. You know that, how the people sometimes react. So, or maybe when you are on the takeoff road, if you are not, you are trying to walk, as it is a small aircraft. You understand? So, bigger aircraft, it's okay. So, it can lead to a crash if it's, but then this is all taken care of. Generally, a pilot cannot take off unless he accepts the aircraft. The CRS is issued by the engineering and the pilot accept it. Second, he has to have the load and trim sheet. He has to accept that load and trim sheet also, so which will give a full understanding to the pilot what is the total weight on the aircraft, how it is doing, where is the CG limit, CG currently, whether the CG is exceeding the forward limit and aft limit during the sortie. So this is, there are people trained to calculate this, and software also can calculate this. In our system we are calculating it. So actually it's a good business model. Let's say if Indigo, if it is operating 150 odd aircraft, each aircraft flying, let's say 10 sorties every day, and 10 sorties every day, then 30 days, every day they fly, and for a yearly revenue, 365 days, and if we charge $1 per load and trim calculation, this is the annual revenue. So many dollars, right? Okay, forget about one as an AD. So SBs are issued by the manufacturer of the aircraft type, aircraft or engine or component. ADs are issued by the regulatory authority of the. So an AD issued by the European EASA, a copy will go to FAA also, but FAA may not issue a corresponding AD. Sometimes FAA also may say, okay, it's basically a tough war. For European issuers issued an AD, so FAA also decided to send an AD for their air. For all US registered aircraft, the airworthiness directives have to be compliant. DGCA, what they'll do is, any AD issued by EASA and FAA, they will issue by default. It's a corresponding AD. So this AD is a very dangerous thing. And when it comes to, when the regulatory authority walk into an airline for an audit, which they periodically do, one of the first questions they ask is, show our maintenance program compliance, that 1,500 tasks which I was talking about. See, they want to see whether any overflying has happened. Second, they will say, where is your AD list? So you show that. He says, show me the compliance, applicability of the fleet, and we're all compliant, and how are you monitoring it? So these are the places people then, when they try to show the Excel sheet, they get bugged. Some service bulletins can be this thick. Some service bulletin can be just 1 or 2 pages. So it depends on the. So I think what we have spoken about it. So the type certificate holder, he is the person who is issuing the SB. not even the manufacturer, the designer. Like it is, a lot of similarities there in the IT industry, where you have a version freezing, thereafter they patch, and then there's a documentation, you know, upgrade version 0.1. So same thing is there in the jargons are different, but here I found that is what I was telling Anu. I only found in software industry you have something called a documentation person whose job is only to document this, whereas this is documented by the designer himself, and till that SB is issued, there is a single point sort of, he takes the ownership. It's not that hydraulic system SB and engine SB, all that, there is one in number documentation team who will keep doing all this. That power plant designer will be responsible for making the document, drawing, that, finite element analysis, whatever you want to do, the engineering analysis. He goes with the designer to, the quality manager to the regulator, convince him, get the ADS SB approved, then he may ultimately send this for a printing to some administrative agency.
The difference is in software, usually the designer is the guy who produces multiple copies of the software. But in a manufacturing-intensive industry, a designer is somebody who gives a working prototype and how to make it, and a production unit runs a long operation to make copies of it. So that is why this responsibility sits with the designer himself. Software also is the same thing. The designer himself is the guy who produces multiple copies of the software because it is just easy.
No, I'm talking about like in the industry, in the software industry, in the other the document also it is there. I'm a owner. I lease it to that Indigo airline. Indigo gives me lease rentals, monthly lease rentals. Typical lease rental of an aircraft is typically around 1% of the value of a new aircraft. So per month. So if I talk about an Airbus A320, it generally costs around $50 million. So 50 million USD, 1% of it is 0.5, 1 by 100, 0.5 million, which is $500,000 I get every month as lease rentals. $500,000 is around 3 crore.
So if you lease it out for 100 days, you can buy another aircraft.
100 months.
Yeah, they can do
100
that.
months. Yeah.
But you need to have $50 million to buy. And the airlines also, very their payment structure, there's a lot of other risks involved. I mean, it's a good business. And
Types of lease.
yeah, there are two types of lease. One is I can lease it on something called a dry lease. Dry lease means I give only the aircraft to the operator. It is the operator who is responsible to maintain and operate and maintain the aircraft. Fuel, spares, maintenance, flying, engineers, everything. There is another thing called wet lease. I am a lessor. I buy the aircraft. Wet lease is also called ACMI contract. ACMI lease. Because these are the things, we used to have marketing people here. Sometime I used to get some email telling from US or UK, it comes in the website. We are an ACMI operator, we are an ACMI organization, we are interested in. So the people never used to understand what is this ACMI. I'm talking about our own people. So again it comes back to me. He says, what reply should we give? So then I have to tell them what is an ACMI. Then I say how it is different from a dry lease, how the software can be used, all that. So that's the purpose of this training in an overall perspective. ACMI means A stands for crew, aircraft. So the lessor gives the aircraft to the operator. Lessor also gives crew, C, pilots also. So lessor has pilots, so you give the pilots also. M is maintenance. So lessor does the maintenance also. Then comes the I is the insurance. So lessor pays the insurance also. The operator has to just tell where to fly and give me the route and give only the fuel expenditure they have to take. Otherwise, no headache of maintenance, crew, pilots, nothing. It's all on the lesser, wet lease provider. But if dry lease is X per month, the wet lease will be at least 3X or 4X charges. Right? So there are two types of leasing. One are dry lease providers and wet lease providers, ACMI providers. ACMI will be in the case of ACMI lease, it is not the operator who is responsible for all regulatory compliances, it is a lesser because he is an ACMI provider. Together? We are together on this. Then is the commercial aircraft manufacturers. That is Airbus, Boeing, anybody, ATR. So I am trying to say MQM, who all can use it? That's what I suddenly realized what it is, MQM commercial aviation. So MQM can be used by the airlines, commercial aircraft operators, MROs. HAL is a standalone, HAL MRO division is a standalone airframe MRO division, MRO, with couple of component repair stations like main gearbox shop and all that. They don't have an engine MRO. So this is where it is. The PBL is all about transferring the aircraft between the operator and the MRO. That I will tell you later. So lessors, manufacturers for fleet management of multiple operators. This is another thing which we were trying to pitch it with the Airbus and Boeing. He says, since it is a web-based system, you implement this MQM at a macro level at US, wherever that, Airbus or Boeing or Lockheed Martin. You monitor, let's say, Emirates, Etihad, whoever it is, using their aircraft. So you get an umbrella view of your complete fleet across the world. So if a defect is happening in Emirates, Airbus A320, MSN number 1, let's say fuel pump failure, I can get to know, I can see whether it is happening in Air China on the same type of aircraft. So I get a global visibility in terms of the defects occurrence, in terms of the utilization, in terms of the incidents, accidents. This is what is required for AI. Then not only AI, it is for proactive maintenance, anything, lot of fringe benefits are there.
Are individual airlines ready to share this data in this format?
No. That's what my pitch tomorrow. I already pitched it.
They only for some.
No, yeah, it is. I am trying to tell this organization. I said you will not able to do it. It's something like this. You have a tank of water, right? And you have a bucket here. This tank of water is in, let's say, British Airways, Lufthansa, all the airlines in the world. Here there is some group called, they want to do AI on this data. Now how it will reach? Unless you put a pipe for the data to reach here, you can't have any AI.
The conflict of interest is the reason why they are not doing it.
I am trying to say,
this is in everybody's
you come
interest.
along, I am trying to say, the manufacturer, you come along, we will brand this product, then it will not be going as Ngraph product. It will be going as that world leaders tag. Walk into British Airways, walk into Lufthansa, walk into 3-4 more airlines. Not too many, 3-4 more airlines. Tell them we will implement this for you and so it's a business development.
How is security? See, problem is when we are asking individual airlines to connect to the same centralized system, even to just give data, there is a higher risk of security, information security issues there.
Security in terms of the data transmission or data which is here? Core data.
Both.
Core data, yeah, this is a lot of, I'm not telling, see, we are not trying to ask about
I'm
the...
not only pointing out a problem, we can address
No,
that.
this has to be addressed.
We can address it.
Because if I'm going to talk about, go to Lufthansa and say, give me your bank information, I understand.
This is very similar for them.
If I'm trying to asking, just give me your defects summary, give me only that access. and I will input back to you with intelligence, with data insights, so that your reliability is under check. So you take money for implementing it here, you also take money to give him insight.
What you're saying is true, but the challenge will be in convincing them that
See, if you or me try to go and convince Lufthansa, it doesn't.
Yeah, if the
But
manufacturer...
if an aircraft manufacturer like Airbus, Boeing or a Rolls-Royce or a GE goes and try to talk to them, the way it is different.
And security, when you exchange, if there is an exchange of data between entities that don't trust each other,
Yeah.
because they are in competition, that we have
I
to
understand,
remember.
yeah.
We can actually introduce a blockchain-like technology there, wherein they don't get visibility into each other's stuff, only the intelligence they get.
Yeah. So those part of it is the challenge. Otherwise, you can sit here and say waiting for data, and if no data comes, then how will you do the analytics? You know, it's very, the data is available in the world in different isolated places. Anyway, that is separate. Okay. Now, typically I am going for an airline. What happens in an airline, or how is an airline structured? You have a board of directors, and the CEO will also come into that block. Then under him you have the HR setup, so pretty much ordinary. You have a CIO, not a CTO, and you have a Chief Operations Officer, and you have a CFO, Financial Officer. Now, this system is relevant for people who are into the operations. CIO, other than becoming a coordinator in the buying process, he doesn't get any useful information from this. Plus, he is not much aware of what these people are doing. So, this software is the prime I will say opinion makers of the system are VP Flight Operations. He heads the flight operations of the complete airline. All the pilots and cabin crew comes under him. Then you have VP Engineering and Maintenance. All the engineering, maintenance, all this AD, ESB, regulatory authority, all that thing comes under him. Quality assurance. Then you have VP Airport Services. He handles the front office activities in the airline. That is generally what we get to see: the boarding, the check-in counters, the luggage management, the taking the bus, managing the buses, the ramp operations. They call VP. There are some people they call it as VP ramp operations also. Then you have a head of flight safety. You have a head of security. The security is the actual security, and so these are the. I mean, out of this system will be of use to this guy, this person. CFO will be still living in the SAP world. He will always ask a question: can your system be integrated with SAP? And that is and these are the cost centers in an airline. HR, like in any other company. CIO, he will generally they do only the IT administration. They don't have any sort of a, and but he becomes a coordinator for. See, in any airline, there are three types of operations. Technical operations, that means maintenance and material management of the aircraft. Then you have flight operations. This is managing the day-to-day flying operations, scheduling the aircraft, operating and all that. Then you have ground operations. This includes even the ticket sales and all that. So what this MQ software is doing is, this software manages the technical operations and flight operations. These are the two functions which are highly regulated in the aviation regulator. Aviation regulator doesn't come and regulate HR functions. He doesn't regulate the CIO functions. He doesn't regulate the CFO functions. The only regulate, so the actual activities in an airline is happening by these two other key people. Airport service also, because he handles the passengers, the front, and the revenue management comes in. So there is no software in the world who handles all these three functions together. technical operations, flight operations and ground operations. There are no software in the world who handles all these three things together. AMOS handles only the technical operations. Ramco handles only technical operations. Majority of the airline, the products handle only technical operations. There are only two companies in the world who has two products in the world who handles technical operations and flight operations. One is MQ with, I will not claim full flight operations, around 60 to 60% of flight operations. There is another company in Bangalore, they also have a good flight ops module but not good technical operations. Complexities of this is mostly in the flight technical operations. The rules, the component hierarchy, I told you about incrementing the hour cycle, all that is the issue here. Flight operations is basically a singing and dancing software where you fetch the weather, you fetch this information, that information using APIs and put it up as in a good, nice looking map and aircraft flying over it and all that. So that is where we have half of it, but we need to do further. And for the HAL, for any airline, they need only for technical operations. For any MRO, it's purely technical. There is no flight operations happen there. Yeah. Yeah, under the VP flight operations, you will have chief pilot, fleet type 1. Like if you go to Jet Airways, you will have a chief pilot for Boeing fleet. There will be another chief pilot for ATR fleet, like that. So they sit with a stick to control these pilots. You know, all the discipline and professional discipline, personal discipline, everything is handled by them. You have a head of cabin crew. Then you have a manager operations control, crew rostering, crew training, flight dispatch. So we have crew rostering, we have crew training, flight dispatch we can say? No. To some extent. And ops control to some extent. Crew rostering for the non-scheduled operations, I told you we have it. But for a scheduled operation, the crew rostering we don't have it. If you just make a crew rostering module for a scheduled operation, I believe Jepsen is a Boeing subsidiary company. I am told that module alone cost $1 million. I have no idea how true that is. If you recollect 3 months or 4 months before, Jet Airways had a lot of flight disruptions and cancellations. The reason was that they were using the IBS software for crew rostering. And we got called from here that he says we are using a company called IBS software. I believe you have a flight duty FTTL software, but we didn't have the bandwidth to go and take it. We didn't even go there. I was in the middle of the... So now they have taken, I'm told that they have taken I don't know what they're called, I just mentioned that Jepsen software. Crew roster is like in an airline like Jet Airways, you will have nothing less than 2,000 pilots. So when you have to roster 2,000 pilots and their flight duty time limits, they have a lot of multiple there. In a civil aviation, before you roster a pilot for a sortie, you have to see multiple things. First, is the pilot available on duty? If he is not on leave, the basic things. If the pilot is on leave, you can't roster him. Second, is it license valid? Is flying license valid? Third, license is endorsed to fly for that type of aircraft. You can't roster an Airbus qualified pilot to fly on Boeing. So, fourth, is training valid? They have a whole lot of training. Monsoon training, simulator training, there are one-time training, there are recurrent training. There are some training which has to happen every 2 months, 3 months, 5 months, like that. So all the trainings are current. Fifth, is his medical valid? Is he medically not grounded? These are all, and then seventh, is FDTL valid? flight duty time limitations based on, there are certain rules, regulatory rules, which says to avoid the crew fatigue, you can't roster a pilot eternally. You have certain rules, like if he has done consecutive 3 night landings, he has to be given 2 days rest. If he has done an international flight more than X hours, he is supposed to be given so much off. Similarly, if he has operated a flight within the window of circadian law, which is morning 2 to, then he is supposed to be not rostered from X time. So there are 5 or 6 page, and our Sandeep knows all these rules. In the middle of the night, you ask him what is the rule, he will tell you with the paragraph number. So, if a pilot is not, if he is rostered for, if I am going to roster it for a Bangalore Delhi, then the system has to apply his predictive FDTL and see whether it is valid, legal. If he is going to violate the FDTL, then that flight is considered invalid or illegal. It's not a legal flight. Tomorrow if the flight go and crash, then the airline is supposed to be actually payable to the people. So they will check whether the FDTL, the pilot is meeting the FDTL requirement. 8, whether the blood relatives are not supposed to be, it's called crew pairing. If I am the pilot, I cannot fly along with my brother or any blood relatives. This is because if I have a sudden bad news, let's say somebody expired, it affects me emotionally. So if both are brothers or close relatives, both will be in the same mood. So to avoid that, blood relatives are not supposed to be flying together. So you cannot be rostered. Then next is called seniority, cockpit seniority gradient. You can't have a captain who is 60-year-old or 55-year-old and a young fellow as a co-pilot, because the co-pilot will be under the severe, he is worried. So your seniority between the captain and the co-pilot cannot be more than X or less than X, At the same time, if you put the 2 youngsters, two batchmates as the pilots, they will start, it happened in the Coast Guard.
It's not allowed, sir.
Yeah, it happened in the crash which happened in 92, Orissa coast. I don't know whether you are aware.
Yes, sir.
It is a disciplinary case. The pilot and co-pilot was never in talking terms. Yeah, they were never in talking terms. There are a lot of HR issues. So this in the IT industry, CRM means some customer relationship management. They call it for a software. But in the aviation, CRM means cockpit resource management, crew resource management. Sorry. So this crew resource management has factors that you brought in here. In this case, all these things will come in.
How do you factor in a factor that 2 people don't get along? Or
No, that we cannot. That actually, in the Coast Guard crash, it has happened that way.
okay.
To be very, the captain and the co-pilot was not in talking terms. When the co-pilot went to the toilet behind,
Off the record.
Okay, so we don't have this crew roster as of now, but hopefully, because we were focused on selling what we have made rather than keep developing. The VP Engineering and Maintenance has, we have a head of engineering. He is also called as Continuing Airworthiness Manager, CAM, Continuing Airworthiness Manager. Under him there will be a Technical Service Manager, you have a Maintenance Planning Manager. What they do I will explain later. You have a Manager Technical Records, under him there are staff. Then you have Head of Maintenance, Maintenance Control Center, Base Maintenance Managers, because you will have multiple bases. Head of Logistics, you will have a Store Inspector, you have a Store Manager, you have a Warranty Manager, Purchase Manager, Logistics Accounts for all his invoice processing and all that. Then you have a Quality Manager, he does the audits. Then you have a Technical Library and Technical Training and Licensing. So this is the setup of if you go to Indigo or Airbus, Jet Airways, you will have a fellow and this setup operates under him. These are a part of the technical operations. Then airport services, he takes care of the reservation and ticketing, so the online booking and all that. Load and trim that I just explained. Catering and all that is under, and all these check-in counters, baggage trolley and all that, front-facing activities, these are all under the airport services. So this is of some particular airline, just took a sort of a snapshot of their organization structure. We are essentially the same thing. How many more airlines?
On 23, so we are on the 8th slide. Let me back up.
We'll back up, no? Then how about we?
Light should be on, I guess. It is dark.
Some lights are required. One or two lights. I think this should be okay. This light, the first one which you switched on.
Then we can see
Is it okay?
That's the last
When you
one.
can
Oh,
see
okay,
this.
okay. Okay, then the other one. It's okay?
Yes, sir.
Good. We have spoken about all this yesterday. I think we were here. This is again of general interest. Pick up only what is required from this. This may not be relevant from a... So the title which the DGCA accept are not this VP, senior VP at all, no. For them the titles are accountable manager, who is supposed to give a declaration to the DGCA that he will give financial resources to safely operate and maintain aircraft being inducted. So he has a financial commitment to the DGCA. That's where Vijay Mallya got into a problem. He was accountable manager for Kingfisher. Vijay Mallya himself was accountable manager. And obviously you must have given it, but then now later on you don't have money to pay the salaries, you don't have money to buy the fuel, all that. So the accountable manager generally will be the CEO or the owner of that company. Others are generally professionals who have the relevant experience. So 5 post holders have to be accepted. For a Deccan 360 cargo airline, I was a post holder for the continuing airworthiness management. I was
For Deccan Airlines.
for Deccan, not Air Deccan, for the cargo, Deccan cargo airline. I mean, this is later part. Everybody ran away, so they never was not getting anybody. So they said, "Can we send your CV?" I said, "Send it." And then the DGCA called me. In fact, I was in NGRAV. I already started by then NGRAV. So, how are you going to do it? So, you can't. So then I thought, these people, the fighters get airborne, and you come and there's a process.
Nowadays, these numbers are fed to the transponders in the aircraft. And the transponder will keep on transmitting these numbers.
Yeah.
By that numbers, this radar will get identified.
Yeah, so this is the basic system. Now what happened, what he is telling, some aircraft are fitted with
Transponders.
transponders.
Now
Now
mandatory, sir. Nowadays.
so there are 2 types of transponders. I'm sorry, I'm digressing. Transponder means, don't get confused. Anything, you ask a question, you reply. That's transponder. A transmission from an aircraft can be just a one-sided transmission, or it can be made to respond automatically. That's called transponder.
Passive.
Yeah, one is passive. This is how the record keeping, I mean, I may be slightly exaggerating, but around 90% I'm okay. And that's where the software also, but then sometime, like if you talk about Indian Coast Guard are not using a software for last, and Indian Coast Guard was founded in 1978. So, and the aviation got started in 82. So 1982, 92, 32, 82, 92, 2002, 36 years of data for on an average of 40 aircraft or 50 aircraft. You can't put that much of history information in this. So even generally in the contract itself we say, but once we induct and start operating, then all the data is there. So last done and next due details of all 1500 tasks. This 1500, I'm just trying to refer it.
Is getting a call.
Yeah, please. that task was last done, and system would have computed when is the next due of that task. Hard time component that I told you, there are some hard time that means
No
which have to be
choice.
replaced. You have no choice, you have to replace it. What is the status of that? Maybe when you land in Dubai, let's say altimeter got replaced or airspeed indicator got replaced, and if the airspeed indicator is, suppose if it is a hard time component as per the AMB, now you have to recompute your next due based on the new serial number which is fitted. Similarly, airworthiness record of the airframe engine, service bulletin, that is a modification status, and each aircraft will have its own structural issues. On a lighter vein, I have seen once that one in the night when I was in the airline, Air Deccan aircraft, there was a nearby Jet Airways aircraft was parked in the night. So during the maintenance, one of the Jeep of Jet Airways, it came and hit the Air Deccan aircraft on the tail, and the Jeep went through that. You understood? So that which was the impact. So you look at the major damage which has happened. So you repair all that, then they put some inspections. Then you can see, when you see this ladder which they come and fix it, you must have seen sometime they come and they will put it. And you will put a dent. So a lot of, an aircraft suffers three types of damage while in the service. When the manufacturer gives an aircraft, he is giving you brand new. I mean, assuming it's a brand new. Then the aircraft suffers three types of damage, and one damage is called accidental damage. Accidental damage. That means while ground equipment came and hit it, or some dent here. So it, over a period of life cycle, there's so much of dent and damages get accumulated on that aircraft. Accidental damage. Next is called fatigue damage. Because for every landing and takeoff, the aircraft airframe is going through fatigue, stresses. This fatigue will result in cracks developing in the body of the aircraft. So fatigue damage will start originating some cracks. And if these cracks are in the places where a maintenance fellow cannot see, it remains unattended. Third is called environmental damage, which is mostly related to corrosion. In our vehicle also this happens. The vehicle fatigue damage is when you are driving, you go and put it in the, all that. So this.
So bird is an accidental damage or an environmental damage?
Which one?
Bird hit.
Bird hit is an environmental damage. Hello, this accidental damage. Environmental damage are because of the corrosion setting in some places. Like there are some areas, even if you send the aircraft for a third level MRO check, they cannot, there are some areas still undetected. And most of the time it is the toilet floor. The aircraft has a toilet. And you will see under that there is a floorboard is there, which we stand. Sometimes what happens, this toilet cleaning fluid is very corrosive. So after every sector, when this cleaning people come and they fill it up, some dripping happens. And some waste water goes down. So when you go for inspections, MRO checks, or when you're doing an MRO check in the operating base, when you see it, you will see a lot of corrosion. So these are all corrosive environmental damages. So because of this reason, an aircraft life is generally limited. Because you can't, it is being accepted that you can't record all the damages and do it. So a passenger aircraft, which is pressurized. See, the pressurization is an important thing because after time limit for it, like now Dorniers are getting midlife upgrade. I was worried actually. The first set of Dorniers came in 82. Still flying. So I wanted to write a DO letter to the chief, without offending the people down below. because I heard that when I saw the crash, when I heard about the crash happened in Chennai, one aircraft zoom into the sea. Nobody know why it went. So this is now 33-year-old, 34, 37 years old. So I wanted to write to him because this, since I know the commercial regulation in the military, this is not. And especially for Coast Guard, because this Coast Guard was growing with this aircraft, or